Hello everyone, welcome to MK Maths. I'm Karthik Mansali. So in last video we have discussed about universal relation and empty relation. So I have done already 3 videos. So in those 3 videos I have completed definition of relation and types of relation. In types of relation I have completed 2 relations, empty relation and universal relation. So now this is the empty relation, universal relation, it comes under a trivial relation. So empty relation and universal relation we call it as a trivial relation. So this is the next part of a types of relation. So reflexive relation. Let us understand the definition of a reflexive relation. So if you want to see the videos of previous relation, definition of relation or types of a relation, universal relation, empty relation, I have mentioned the playlist in description so that you can watch those videos and first understand those concepts. Next you can watch this reflexive relation. If you already know the definition of a relation and types of a relation, so directly you can watch this reflexive relation. Okay, so let's move to our topic today. In this video I am going to explain about the reflexive relation, definition of reflexive relation, and let us see some example about the reflexive relation. So, okay, so reflexive relation, the word reflexive itself says here, the word reflexive means it comes from the word reflection. Okay, so if I consider this is a mirror, if I consider this part is a mirror. Okay, if one person is standing in front of a mirror, his reflection will be in the mirror. His reflection will be in the mirror. So it means we are creating a relationship between himself only. So he is standing in front of mirror and his reflection is in front of his reflection is in mirror. So now we are creating a relationship between him and himself only. Okay, so this is nothing but a reflexive relation. Reflexive relation, it means a person creating a relationship between himself. If any relation is any relation is works, any relation happens to himself, then that relation will be a reflexive relation, means it is a reflecting to himself only. So this is nothing but a reflexive relation. Okay, so let us see the definition of a reflexive relation in mathematics. So the definition says, for all a belongs to a. So this symbol we already know, this is for all a means this is element, this is element of a, set a. I have considered set a. In that set a, for all elements of a, means if a set having a 4 elements, we have to consider each and every 4 elements. So we should not miss any elements in the set a. If a has a 5 elements, we should consider those 5 elements, each and every element, without any miss. Okay, so for all a belongs to a means, that is the meaning, we have to consider each and every element which is present in the set a. This symbol is nothing but implies. Okay, this symbol is nothing but implies. Implies means this left side arrow, this implies a symbol left side part saying for all a belongs to a. This condition moves forward to this condition. Now this condition is nothing but ordered pair a comma a belongs to R. Ordered pair a comma a belong, or we already know that ordered pair a comma a means a is related to a itself. A is related to a itself. That is the basic meaning of reflexive. Okay, already here we discussed the reflexive in general way by using mirror. Okay, if a person is standing in front of a mirror, he himself is a reflecting. In same way, if a is related to a, if a is related to a means, then that R will be reflexive relation. It means every element of a is related to itself. If you consider any element from the set A which is related to itself, then that R will be reflexive relation. Reflexive relation is nothing but a relationship happens to itself. There is no need of other person. So to create a reflexive relation, if to create reflexive relation, if there is a one element, that's enough. That for one element it can create a relation to itself. Okay, so same. Now what I have explained, this is in symbolic mathematical way. So same definition I have written in sentence. Okay, so let us understand that definition also here. If R is said to be reflexive relation in set A, in particular set A, R is said to be reflexive relation. This R, if we want to say this R is a reflexive relation, then it should satisfy some condition. Here the condition is for all elements of A. For all elements of A means this part only. Here we have written in symbol, using symbol. Here we have written in sentence form. For all elements of A is related to itself. If you take any element of A, it should relate to itself. So relate to itself means this is the symbol. We represented ordered pair A comma A. Actually we represent ordered pair as A comma B. Okay, in the place of B we have substituted A itself. In the place of B we have substituted A itself, because that we are creating a relationship between itself. So now both become same, A. In the place of B also we replaced A only. So this is the definition. So if you not understand definition, then move to example. So after explanation of an example, definitely you are going to understand the reflexive relation. So you just understand one thing before going to example. You just understand one thing. Reflexive relation means here we are creating a relationship between themselves, between itself. If considering a element A, we are creating a relationship to itself. That's all. So okay, there is no need of another element. One element is enough to create a relation for itself. So now let's move to example. So in general I have considered here a friendship relation. So if for example A is the person, he can be friend to himself. Okay, he can be friend to himself. Means any person in the whole world can be friend to himself. Means friendship relation is this friendship relation is nothing but reflexive relation. This friendship relation is nothing but reflexive relation. To become a friend, there is no need of other person. You can be friend to yourself. Then that friendship relation is a defining for yourself. Then this friendship relation is nothing but a reflexive relation. Means this friendship relation is reflecting to yourself. If you consider a mirror, if your reflection will be present in the mirror, then you and the reflection part can create a friendship relation, because in the reflection part is nothing but you only. So it means a person can be friend to himself, then that friendship relation become a reflexive relation. We can call this friendship as a reflexive relation here. Okay, so let us understand now. In general way we have understood friendship relation is reflexive relation because everyone can be friend to himself or themselves. So in mathematics, so let us understand with example. So in previous two relation, universal relation or empty relation, I have considered A equals to 1 to 3. So I am maintaining that example only because it is convenient or easy way to understand. If we consider one example and understood all the types of relation, then it will be easy to grasp the all the types of relation, so without any confusion. Okay, so now I have considered A equals to 1 to 3. In previous types of relation also I have considered same example. So A equals to 1 to 3. So now I am creating here relation R. Now I am creating relation R. relation R. So here we have 1 2 3. So definition says for all A belongs to A. For all A belongs to A implies there should be A comma A belongs to R. There should be A comma A belongs to R. It means for all A belongs to A means here A contains element 1 2 3. So if we consider 1 should be related to 1. Okay, 1 should be related to 1 and 2 should be related to 2. 2 should be related to 2 and here 3 is related to 3. 3 is related to 3. If I closed here, now this R will become reflexive relation. this R become reflexive relation because it satisfies every element of A, satisfies R. A relation, every element of A implies A comma A belongs to order pair. A comma A belongs to A means every element of A is related to itself. So for example, if I consider 1, here 1 is related to 1. If I consider 2, here 2 is related to 2. If I consider 3, here 3 is related to 3. Then it is a reflexive relation. Let us make it as R1. Okay. Now I consider it as a R2. R2. So if I consider 1 comma 1 and 2 comma 2, so I close the relation. So now this, if we check, we verify with the definition, then it's not satisfying the definition. See for example, so 1 is related to 1, okay, well and good. 2 is related to 2, okay, but 3, in set A we have a element 3, but here 3 is missing. So in this R, 3 is missing. So in this R, this 3 comma 3 is missing. This 3 comma 3 is missing. If one element is not related to itself, then obviously we can say it is not reflexive. Not reflexive. To R, if R should be reflexive relation, means each and every element of A is related to itself. Each and every element of A is related to itself. If any one element is missing this relation, if any one element of the set A is not related to itself, then obviously we can say it is not reflexive. Okay. So let us see another example. R3. Now I am considering R3. 1 comma 1. Okay. 2 comma 2. Okay. Next 3 comma 3. Next I have considered another 2 comma 3. This is extra relation. Okay. But we have to focus only every element of A is related to itself or not. If extra any other relations are there in R, no worries. So let us check the definition. So here 1 is related to 1, okay. So 2 is related to 2, okay. 3 is related to 3, okay. That's enough for us because in set A we have 1, 2, 3. We have each and every element of A is related to itself. 1 is related to 1, 2 is related to 2, is related to 2, 3 is related to 3. That's enough. If in R, if there is any extra relation, if there is any extra order pairs, it doesn't matter. We can conclude that this R3 is reflexive. If R3 is reflexive relation, okay. Here R1 is reflexive relation because it satisfies the definition. R3 is a reflexive relation because it satisfies the definition. Satisfies the definition means every element of A is related to itself. So every element of A means 1, 2, 3. Element of A contains 1, 2, 3. So it is related to itself means 1 comma 1 is there, 2 comma 2 is there, 3 comma 3 is there. So extra, if there is any extra ordered pairs in R, it doesn't matter, but it should be 1 comma 1, 2 comma 2, 3 comma 3. Then it is a reflexive relation. Okay, I hope you all understood. So if I consider R4, is 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4. Okay. Now 1 comma 1 is there, 2 comma 2 is also ordered pair, 3 comma 3 means 3 is related to 3, but here observe 4 comma 4 is there. Okay. Extra I have written 4 comma 4. 4 comma 4, this 4 is not belongs to A. This 4 is not belongs to A, then definitely it is not satisfying the relation. It is not reflexive relation. Before to say this not reflexive relation, first of all it is not a relation. First of all, it is not a relation because this R4 is not a subset of A cross A. in A cross A there will be a no 4 comma 4. This is a extra order pair which is not present in A cross A. Then it is not a relation. If it is not a relation, then there is no need to discuss about reflexive or not reflexive. Reflexive or not reflexive only comes under when the given R should be relation. That point also we should remember. If R is a relation, then only types will comes under that relation. If R is a not relation, we can't define any type of the relation. We can't name any type of the relation. Okay, I hope you all understood this reflexive relation. If you have any doubt in this topic reflexive relation, or if you have any extra example, you can feel free and use the comment section. So you can comment and ask the doubts there. So I will clarify your doubt if possible. Okay, thank you for watching. In next video I am going to explain about symmetric relation. Okay, tata, bye bye.